Good morning, ladies and gentlemen. Today is Thursday, March the 11th, and this lesson is on this section 5.2, special triangles. And there's actually two famous triangles. If you have that trigonometry set that your parents might have given to you, one's a triangle that looks something like this, a scalene right triangle, and one is actually an isosceles right triangle. These special triangles are used immensely to find exact trigonometric ratios. I would actually rather you you problem solve and learn these triangles rather than memorize a chart. There's actually a chart system that actually works well too, and it's neat, but I'd rather you look at this. And so the first scalene right triangle has the interior angles of 30 degrees here, 60 degrees here. This is the famous 30, 60, 90 triangle. And it doesn't really matter what the sides are. However, these proportions of sides, with respect to this 30 degrees, this side will be 1, this side will be 2, and this side will be root 3. How did I get root 3 so fast? Really easy. Using Pythagoras, 1 squared plus something, let's call it y squared, is equal to 2 squared. 1 squared is 1, y squared is equal to 4. Subtract 1 from both sides, we get y squared is equal to 3, and then therefore y is equal to root 3. So a lot of students memorize this question as 1 to root 3. And it is associated with the 30, 60, 90 triangle. So notice what we have. We have angles and we have sides. How about this one? The isosceles right triangle. With the isosceles right triangle, notice this is 45 degrees, and this is also 45 degrees. Unlike the scalene right triangle, this one is also pretty easy. So these two sides must be congruent, because it's isosceles. So what is this side? This side is 1, and this side is 1. Can someone from the class help out Mr. Chen? Do you think you could tell me exactly what is the hypotenuse? And I'll give you a hint. We're using the Pythagorean theorem. I'll stop there. Hi, Adam. Root 2. This is the famous 1, 1, root 2 triangle. Or some students know this as 45, 45, 90. Now, how do we use this? I'm going to give you guys an example right now. Can I get a volunteer to tell me what is the cosine of 60 degrees without using your calculator? So which triangle do you think we're going to use? Do you think we'll use the first triangle, or do you think we'll use the second triangle? Karen?
The first one.
First one, because it has a 60 degrees. Can someone now answer the question without using your calculator? What is the answer? Just like that. And again, if you need some help, we have the mnemonic so, ka, toa. Adam again. 1 over 2 is correct. See how fast I got it? This side is the adjacent to 60 degrees. This 2 is the hypotenuse. Cosine is the adjacent hypotenuse. Just like that. Let's see if someone can help us out still. Can I get a volunteer to give us the sine of 45 degrees? Just like that. And if you need some help, which triangle do you think we should use? The first one or the second one? Claire? 1 over root 2 is a great answer. However, notice this answer is a great answer, and conceptually it's good. But I taught you something. We mathematicians do not like radicals in the denominator. Can I get a volunteer to extend Claire's answer and rationalize this answer? Does anyone remember to rationalize this answer? Tom?
You multiply by its, what do you call it again?
Oh, you
Root 2 multiplied by itself, I guess, in a way.
Sure, multiply by itself. What does it solve?
Root 1 over root 2. Or root 2 over root 2.
Is correct. So what's our final answer?
Oh, that would be root 2 over 2.
Nicely done. Way to go, Tom. So notice these do not look the same, but they are the same. So don't get me wrong, what Claire did was really, really important, 1 over root 2. And don't get me wrong, I'm just asking, if you might see in your text with a rationalized answer, you're not wrong. Okay? Any questions about this? Let me show you the chart. I don't really like the chart, but I'm going to just show you really quickly. Some tutors teach this. So we said between 0 and 90 degrees, they're not really written in the angle question. So don't panic. I'll explain in a moment. That's 0. That's 1 over 2. That's 1 over root 2. That is... what is that? Root 3 over 2. That's 1. Now, I know it doesn't look great, right? How do you use it? The sine of 30 degrees is this answer. Want to see what I just did? So a lot of tutors teach this way, but let me show you the subtleties of how we got it. Technically, if you were listening to your classmate Tom said to me 1 over root 2, and again, this was Claire's answer. Technically, this is root 2 over 2. So notice the pattern here. Watch what I'm going to do. Root 1 over 2. Well, what's the square root of 1? It's 1. And what's this one? Square root of 0 over 2, which is 0. So what's this one? Square root of 4 over 2. What's the square root of 4 though? 2 over 2. So notice the pattern? Root 0, root 1, root 2, root 3, root 4. Everyone see that pattern? Notice the denominators? 2, 2, 2, 2, 2. So a lot of tutors teach this way. Cosine, watch what it is. It's just the reverse. And what's tangent? Tangent of 0 is 0. Tan of 90, no answer. Tan of 30, what's tan of 30? Opposite over adjacent. 1 over 3. And tan of 60. So I actually don't memorize this. Tan of 60 is root 3 over 1. This one's a little harder to imagine. So some tutors might use this, and some students do memorize this pattern when they want to know exact answers. But it's kind of neat, right? The red, what I wrote. You don't have to know this. I'm just trying to share it. I actually would rather learn this. Okay?